Welcome to Enzyme Inhibition, a series of short videos that introduces you to enzyme inhibitors and their effects on enzyme kinetics. We'll start our discussion by discussing different types of inhibitors. To get the most out of the videos, I recommend that you watch them in order. This is a reminder that this presentation is Dr. Johnson's intellectual property. What is an inhibitor? Quite simply, it is an ion or molecule, big or small, that binds to the enzyme and by doing so slows or stops the enzyme's action on its substrates. The inhibitor interferes with catalysis. Inhibitors can be divided into two major kinds: reversible inhibitors, which may be competitive, uncompetitive, or mixed, and irreversible inhibitors, which include very tightly binding inhibitors and suicide substrates. Our focus will be on the reversible inhibitors. Here we see a kinetic model for reversible inhibition. In this model, the inhibitor can bind to free enzyme or the ES complex, or both. The two inhibition constants you need to be concerned with are the KIC and KIU. The I stands for inhibition, the C for competitive, and U for uncompetitive. With competitive inhibition, the inhibitor binds at the active site of the enzyme, preventing the substrate from binding. A simple way to understand competitive inhibition is that the inhibitor and substrate are competing to bind to the active site. This mode of inhibition has only the KIC term. Uncompetitive inhibition involves the inhibitor binding to the ES complex to make the ternary ESI complex and has the equilibrium term KIU. One way to understand this type of inhibition is that it occurs when the inhibitor binds to an allosteric site on the enzyme, changing the conformation so that the product cannot be formed. In mixed inhibition, the inhibitor can bind to either the free enzyme or to the ES complex, giving us an EI or ESI complex, so that there are two equilibrium constants, both of which you've already seen. In addition, it is possible that the EI complex can bind to substrate to produce an ESI complex, which will also have an equilibrium constant, K'S, which could be different from Ks. Like uncompetitive inhibition, mixed inhibition could occur by binding of the inhibitor to an allosteric site and a conformational change that slows catalysis. There is some evidence that for some enzyme mixed inhibitor combinations, product can be formed from the ESI complex, albeit at a slower rate than from the ES complex. After all, it would not be an inhibitor if the rate was not slowed. Another way that mixed inhibition could occur is for the inhibitor to bind in such a way that it blocks access to the active site without binding in the active site. This would allow the inhibitor to bind the enzyme regardless of whether the substrate was already bound. Kinetic studies are required to establish which of these modes the inhibitor uses. These also have the benefit of providing information regarding the strength of inhibition. That's what we'll look at next time.